October, November 2015, paper 4, variant 3, the very last question on the paper, which is about number patterns and sequences. And there's one question, one particular question, the last part of this question, which is kind of slightly different from what normally comes up, but it's something that I have gone through with my class. I'm going to today show you a slightly different way of doing it at the end. So let's start with sequence A. Now, sequence A is the simplest type of sequence that we normally find. And if you just always, when you look at a sequence, try to see if there are any number that you have to add or subtract to each term to get to the next term. And here we can see 15 to 8, you've got to take away 7. 8 to 1, you've got to take away 7. 1 to minus 6, again you've got to take away 7. So it looks like the sequence goes down by 7 each time. So the fifth term is going to be 7 less than minus 6, which is negative 13. And the sixth term will be 7 less than minus 13, or negative 13, which is going to be negative 20. Okay? Now if you want to find the nth term, as it's going down by 7 each time, it has some relationship with the 7, or the negative 7 times table. So it's going to have some relation to minus 7 times n. Okay? Whoops. Minus 7 times n. Now minus 7 times n. One second, let me just put the battery in. Okay. Minus 7 times n. There we are. It will not give us the required numbers. However, it will make the sequence go down by 7 each time. When n equals 1, I'll have minus 7. When n equals 2, I'll have minus 14. When n equals 3, I'll have minus 21. So it will be going down by 7 each time. However, it will not start from the correct place, which is 15. So I need it to go down by 7 for each term. However, I want the first term to be 15. So I have to say, what do I have to do to go from minus 7 to 15? We'll have to add 22. So if I add 22 to this minus 7n, what will happen is I'll have my first term as 15. Okay? So the first term will be minus 7 plus 22, which is 15. The second term will be minus 14 plus 22, which is 8. The third term will be minus 21 plus 22, which is 1, and so on. And you can always check to see if your answer is actually sensible by trying to, by trying to check for any particular term. So for example, let's say I check for the fourth term. I will check with a term that I already know from the question rather than one that I had to calculate in case I made a mistake. So you have 7 times, minus 7 times 4, negative 7 times 4, which is negative 28. Negative 28 plus 22, that will give you minus or negative 6, which is the correct number in that term. Therefore, I know that I've got the right sequence. Okay, for sequence B, here you have a fraction. Now, it's no good looking at the fraction as a whole. What we can do is look at the fraction as a numerator with one pattern and the denominator with another pattern. So here we have 5, 6, 7, 8. All right, obviously, it's going to be 9 and 10. And for the denominator, we have 18, 19, 20, 21. Pretty simple pattern. 22 and 23. Okay, now, we want to find the nth term. So again, we'll take the numerator separate from the denominator. Now the numerator, it's going up by 1 each time. Each term increases by 1 each time, so it's got something to do with the 1 times table. So it's 1 times n, should say n. However, that's not enough. If I leave it at that, my first term will be 1. I want the first term to be 5 for the numerator. Okay, so I have to add 4 to 1 to give me 5. When I put n equals 1, I'm going to have 1 plus 4, which is 5. N equals 2, 2 plus 4, which is 6, and so on. So it's going to start from 5 and go up by 1 each time. And similarly for the denominator, it's going up by 1 each time, so it's 1 times n, which is n. And you see that the first term has to be 18. So you have to add 17 to this to give you 18. So you have n plus 4 over n plus 17. Okay. Now for part C, okay, this sequence here, it's going up by 3. And it's going up by 5. And it's going up by 7. Okay, so here we have a sequence which is it's not a linear sequence, it's a quadratic sequence. Okay, it's a quadratic sequence. Okay, because it's going, the second row of differences here is 2. Okay, if you look at the second row difference, you're going to have +2 and a +2. So this is going to be like, it's going up by 3, then by 5, then by 7. Then I go by 9, so that's going to become 26. Then it's going to go up by 11, so it's going to be 37. So I know, because the second row of differences is 2, it's got something to do with n squared, 1n squared. Okay, you see the second row, whatever number comes up there, you have to divide it by 2. So the second row is going up by 2, you're going to have to divide that by 2. You have it'll be 1n squared. If it was +4 +4 +4 in the second row, you'd say 2n squared. If it was +3 +3 +3, you say 1.5n squared. Okay, now this particular sequence is pretty simple because we can see each of these numbers 2, 5, 10, 17, 26, 37. If I write the first squared number, which is 1, and the second squared number, which is 4, and the third squared number, which is 9, then you have 16, then you have 25, then you have 36. I can see each of these terms is 1 more. So this is n squared. I have to add 1 to get to the term I have. And from this, I have to add 1 to get to the term I have. I have to add 1 to 9 to give you 10. Add 1 to 16 to give you 17. Add 1 to 25 to give you 26. Add 1 to 36 to give you 37. So you can see the sequence is going to be n squared plus 1. Okay, it's not n plus 1 squared, n squared plus 1. You have the squared number, and each of the terms is 1 more than the squared number. Okay? So that's sequence C. Now sequence D, 2, 6, 18, 54. Okay, now, this is not a sequence. If you add something to each term, it doesn't give you a common number on the first row nor the second row. Okay, so it's not a linear or a quadratic sequence. However, we can notice that if we divide the term by the previous term, we end up with the same number each time. 54 divided by 18 is 3. 18 divided by 6 is 3. 6 divided by 2 is 3. So you have to multiply by 3 each time to get to the next term. So the next term after that is going to be 54 times 3, which is 150 plus 12, which is 162. Then you have 162 times 3, which will give you, let's just use a calculator for that. That will give you, what is it? We've got 162 times 3, which gives you 486. So 486. Okay, so that is the term on the sixth term, 486. Okay, now, let me just make that a bit neater. It's a bit messy there. So that's 486. 486. Now, this is a quadratic, an exponential sequence. We have to multiply by a certain number each time to get to the next number. Now, in order to get an exponential sequence, you have to realize that the number you're multiplying by to the power of n will be the form of the sequence. It's going to be something related to 3 to the power of n. Okay, so what I'm going to do now is I'm going to take the first term, which is 2, second term, which is 6, third term, which is 18, fourth term, which is 54, and so on. I'll just use those for now. And I'm going to write this as something to do with 3 to the power of some n. Okay, 3 to the power of n. Okay, so this is 3 to the power of something. And this has got something to do with 3 to the power of something. And this is 3 to the power of something. This is 3 to the power of something. So there's going to be a power here that I have to use. Okay, so here, if you look at the first term, it's 3. Okay, the first term is 3. Now, how on earth do I get 2 when I have 3 to the power of something? Okay, so what you can do is you can say, okay, I know that 2 is 2 times 1. And 3 to the power of 0 will give me 1. So I have 2 times 3 to the power of 0, that's going to give me 2. And I know that 2 times 3 is 6. So if I have 2 times 3 to the power of 1, that's going to give me 6. And I know that 3 times 3 is, 2 times 9 is 18. And I know that 3 to the power of 2 gives me 9. So this is 2 times 3 squared, which is 9. And I know that 2 times 27 gives me 54. And 2 times 3 to the power of 3 is 2 times 27, which is 54. So I can see that for the first term, okay, for the first term, I need to have 2 times 3 to the power of 0. So the first term is 2 times 3 to the power of 0. So this is n. The second term, I have 2 times 3 to the power of 1. The third term, I have 2 times 3 to the power of 2. The fourth term, I have 2 times 3 to the power of 3. So the nth term, I'm going to have 2 times 3 to the power of, but it's always 1 less than what n is, isn't it? Okay, for example, if I wanted to find the 15th term, I'd have 2 times 3 to the power of 14. So this is going to be, the nth term is 2 times 3 to the power of n minus 1. Okay, this is like the way, kind of like to do this by deriving from kind of first principles. Okay, there is another way which I did not teach my class during the term because I prefer for students to have some sort of an idea or an understanding rather than being memorizing like parrots. But before the exam, of course, you know, some of these shortcuts can come in useful. So I will explain now at the end how to do this using a simple formula, which is derived in a way that we actually derived the answer for this question. Okay, and that is basically the nth term for a sequence which is exponential or geometric, as it's called, is un is a times r to the power of n minus 1, where a is the first term of the sequence, okay, and n is, sorry, not n is the term that we're looking for, and, r is what's called the common ratio. So we have a is the first term, and r is what's called the common ratio, which is the 3 that we had here. It's a number that you find that you have to divide by each time. The common ratio here is going to be 3, because each time to get to the term after it, you have to multiply by 3. Okay? So a term divided by the term before it will always be the common ratio. The common ratio is 3, and the first term, as you can see, is 2. Okay? So the common ratio is 3, and the first term is 2. So if you want to write the formula in this way, you're going to have 2 times, and you have 3 to the power of n minus 1. And you can check if this works. Okay, if you see if this works, for example, let's choose for the, say, first, second, third, let's say the third term has to be 18. So for n equals 3, you have 2 times 3 to the power of 2, 2 times 9, 2 times 9 is 18. So we see that we're correct. So here we have the answers to our question. Okay? All right. Thank you very much for listening.